Going to talk about optimizing multi-well pad site production. And so when we look at multi-well pads, a lot of this is brought about by the industry trend, increase of horizontal wells. It's led to more and more multi-well pad sites. In some locations, multi-well pad sites are becoming the normal. 90% of your wells are either horizontal or directional drilling. And then you're bringing in multiple well pad sites with, and these are becoming more and more complex systems. You've got tank batteries, you've got vapor recovery units, three-phase separation, your well pad site. So it's extending beyond just traditional single well control. You'd have a single hole in the ground and bringing up a small RTU right there. So it causes the IO counts to increase. So like we said, pump jacks, holding tanks. A lot of times you've got a LAC system on these locations, and a LAC system is used to measure the oil pumped into the trucks and pipeline. All of this has been brought about by the benefits of horizontal drilling. Horizontal drilling allows you to go ahead and minimize your location, your topside location. And so now you're bringing in multiple wells into a single location, as opposed to putting well pad sites all over with RTUs at each one of those well pad sites. So in a lot of applications you see in these multi-well pad sites, you've got a dedicated flow computer. You'd have a system similar to this with a dedicated flow computer that's measuring your production. And then you'd have a PAC that is going ahead and communicating with your field IO, grabbing your tank levels, and a lot of times you're doing a communication back and forth between your flow computer and your automation controller. Oftentimes also you need to have communication back to a SCADA host, and so you're putting in a separate RTU or a gateway type device to communicate that information back out to the SCADA host. And so there's multiple pieces of equipment out there. Each one of them has their own programs, their own programming software, and requires revision control on all those devices. And so you've got a lot more complexity with trying to do a scenario like this. One of the things that we've been able to do is work on an integrated flow measurement device. What this allows you to do is take that same amount of I/O that you were doing on with other devices, pull it into one system, one Controllogix or Coprocessor processor. It's all built on a Logix architecture, very scalable. You can scale the application to what you need. You can use a L24 Coprocessor controller with built-in I/O for smaller systems. You can go up to L30s for larger Coprocessor systems, and then go into Controllogix if needed for full redundancy. So it gives you a lot more flexibility than your other systems. Also gives you, being as it's expandable, built on Rockwell architecture, gives you the capability to go ahead and bring in multiple points of I/O and really build out systems that exceed the systems that you're currently able to do with dedicated flow computing device. So what we do is a coprocessor unit here. And so you've got your process inputs that are coming from your measurement devices, your different pressure and temperature values. That gets brought into the PLC and then passed out to our coprocessor module. That coprocessor module goes ahead and handles all the AGA and API flow calculations. It stores that data into a secure memory location in the module. It's stored in non-volatile memory, and so it meets your specific API requirements for being able to do archiving of data. And once the archived data is in the device, it can't be altered or changed by anything in the PLC code. So for the calculation methods that we support, we can support up to 16 meter channels on Controllogix, 8 meter channels on Coprocessor systems. We support both differential and linear, AGA3 and AGA7 and 8. And we also, on the same piece of hardware, we support both liquid and gas. So there's no separate licensing requirement. You don't have to buy one piece of hardware and then get a separate license for liquid calculations. It's based on number of meter runs. If you buy a card and it's 8 meter runs, then each of those 8 meter runs can be all liquids, they can be all gas, they can be any combination that you want right there. Calculation methods are the standard AGA 3, 7, and 8 calculation methods, as well as API Chapter 11 and 12. For data archiving, we can support up to days or 48 hourly records, 1 month or 35 daily records, and then a total of up to 1,440 of each record, hourly and daily. So a total of 60 years worth of hourly data and like 3 years worth of daily data. Each of those archived records is cut automatically by the card, so when your contract period is over, based on end of day, end of hour, that record is automatically cut by the card, and that is stored in the module. That information can be retrieved through a SCADA host. It can be retrieved in the PLC itself. There's several different methods of retrieval to get that hourly data. Based on it is a scalable architecture, so like I said, if you were using a L24, L27 processor, you could utilize the built-in I/O that's located directly on that L24, L27 processor. Bring your process input signals directly into the Controllogix PLC. This gives you a really cost-effective solution. There's not a separate power supply. There's not separate analog cards. These are systems that can be used on small-scale systems, can be used on things like LAC systems, and where you've got a small amount of control that you need to do and a small amount of I/O. And or it can be scaled to a mid-range system where if you're using an L30, 33, or 36 processor, you can utilize multiple modules. If you need more than 8 meter runs that we support on the current unit, you can put 2 cards in there. You can build out your I/O system as much I/O as you need. You can add distributed I/O if needed. You can do expansion racks. It's fully supported within the Rockwell architecture. So what you can do with you're only limited by power supply distance ratings on Controllogix systems, and then the total amount of available memory in the processor that you have. When we Controllogix, you've got a bunch of different options right there. You can do integrated with analog channels, or you can go ahead and utilize gateways to do Modbus communication directly with multivariable transmitters. You can support distributed applications, and even in some cases safety applications. So you've got a lot of flexibility being built on the Rockwell architecture. And one of the things that with Controllogix, Controllogix, you can develop add-on instructions, user-defined data types, and those are easily ported between the 2 different systems. So you can reuse some of the code that's, if you develop on one platform, you grow out of that platform, you can go ahead and port that over to a larger processor and still reuse a lot of that work right there. And that was it. So if you have any questions, we got a little demo pad right here.